Right, so today I am going to teach you Advance C13 NMR spectroscopy concept. I want to teach you this because later I will be teaching depth and inept spectra topics from C13 NMR spectroscopy, which is very important for CSIR. So before I jump to that topic, I thought it's important for you to understand the basic concept behind the C13 NMR spectroscopy. This is fifth time I'm recording this topic. You can see the rough work I have done here. Because of the bad clarity, the focusing problem in my phone. I apologize for that problem. Surely I'll fix that problem. Till then, I request you to please bear with this clarity. So what basically what is the reason behind making this video is that the intensity of NMR signal, it totally depends upon the gyromagnetic ratio gamma. Okay, as it depends upon the gamma, but for C13 nuclei this gyromagnetic ratio value is very less, okay, compared to proton. Like I can say the proton value, just a minute, the gyromagnetic ratio of C13 is 4 times less than that of proton. Okay, so as it is 4 times less than that of proton, uh, basically what I am doing here is that we'll increase the intensity of C13 by coupling it with a proton. Now this is the requirement, that when you have a nuclei of less gyromagnetic ratio, you couple it with a nuclei having more gyromagnetic ratio value, so that the cross polarization technique becomes easy, that is the population inversion. Don't get worried with the terminology. At the end of this video I'm sure you're going to love the concept. Okay, so what basically we do here is that we take the 4 energy levels. The first energy level with the 2 up spins, that is plus half proton and plus half gamma C13. Gamma is your gyromagnetic ratio. The another 2 degenerate levels, one is up and down, another is down and up, and the upper one is with 2 up spins. Okay, so this looks little complicated. Now I'll simplify this by simply adding plus half proton and plus half C13 to each energy level. So if I add plus half proton here, this will become 1, and this will be also 1 because we are adding plus half and plus half, and this will become plus half 1, and plus minus gets cancelled out and it becomes only gamma proton. Okay, and here we will get only gamma C13, and here it becomes 0. Okay, I'm getting worried because of the screening by the bad focusing. Anyways, okay, so once you add all that, what happens is that you'll get this level. Now as I told, the C13 is gyromagnetic ratio is 4 times less than that of proton. So if proton is 4, this is just 1, so this value will become 5, right? It's not that the proton gyromagnetic ratio is 4, but as this is 4 times less than, as this is C13 is 4 times less than that of proton, this value will be 5, and here the proton value 4, the C13 value is 1, and here it will become 0. Okay, now what happens is that you have to apply a 180-degree pulse. Here is a requirement, that why do you apply pulses in your C13 NMR spectroscopy. Now if you apply pulse, what happens is that the inversion of the population takes place. Okay, so the 4 will come out here and 0 will be here only, and this will be as such. Now you can see that the difference for the C13 here, 5 minus 4 is 1 and 1 minus 0 is 1. So 1:1 is the intensity ratio here. Later what happens, after applying pulse, the difference you can see for C13, it becomes 5 minus 0 and 1 minus 4, that is minus 3. So now it will be minus 3:5. So as this is minus 3:5, you can see previously it was 1:1. So there is enhancement in the intensity, and this enhancement is very important to record the spectra of C13 NMR. Okay, so this is what basically, the mechanism is, that what is the need to apply the pulses. Now it is required to enhance the intensity. What else is important here to understand is that you have to couple your C13 which has less gyromagnetic ratio with the nuclei having more gyromagnetic ratio like proton. Now once you couple, what happens is proton will give away its magnetization to the C13 nuclei. It does here in the last step. The proton, on applying 90-degree pulse here, after this the proton will give away its magnetization to the C13, that is less abundant nucleus. Okay, so this cross polarization technique, whatever I am explaining here, it can be achieved only by using selective pulse radiation. You can't apply here 90 and here 180. You have to apply 180 only here. Okay, so it is very specific. Hence we say very specific pulse radiations are used in your advanced C13 NMR spectroscopy topics. So later I will be making video on depth and inert spectra, which will be helpful for you for your entrance point of view. Right? Thank you.